Welcome to 3 Steps to Sketch. In this video, we'll go through the method for graphing basic unshifted cosecant graphs that are in the form y equals a cosecant bx. So again, no shifts. A couple notes. Cosecant is the reciprocal of sine, and we're going to make big use of that fact. So if you aren't familiar yet with how to graph sine equations, go check out those videos first and then come back to this, and that will make this 1,000 times easier. That's just such an integral part of this method. Okay, one other thing. Note that this is the method for basic, so again, unshifted cosecant graphs. If your graph is shifted, then we'll have to make a small adjustment to this method, and we'll look at that in a later video. All right, so here are the 3 steps to sketching unshifted cosecant graphs. The first step, we'll find a companion equation, so that'll be the reciprocal equation, sine, and a lot of essential information. Step 2, we'll plot the companion pattern, that's the sine pattern. And step 3, we'll recip, sketch, and repeat. So recip is just the verb form that I've created for reciprocal, and that's changing or taking reciprocal values so that you can get the cosecant graph from the sine graph that we'll have sketched. Now I'll have a template for this at the end of this video, but for now we're going to break each of these down into smaller pieces so that we really get the feel for what goes on in each step. So step 1 is to find the companion equation and its essential info. Okay, there's the reminder of the form of equation we're working with. All right, like I said before, our companion equation is going to be the reciprocal equation of cosecant. So all you'll have to do is replace the cosecant with sine. And we'll find the essential information. And you'll notice that this part will be exactly the same as if you're graphing the unshifted sine equation. You are doing that. So if you already know how to do that, you have a large part of the battle already tackled here. As a reminder, we will find a and b. The absolute value of a will tell us the amplitude of the sine graph. That's just the distance from midline to max or midline to min. B will tell us how many cycles happen between 0 and 2 pi. And we'll also use it to calculate our period. Remember, that's just the horizontal length of a cycle. So we'll do that 2 pi divided by b. We'll also go ahead and label our axes. So we'll choose our scale labels, being very particular for our horizontal axis. We'll take our period and divide by 4. And what this does is it allows us to graph very neatly, and so that each of our points in the next step for plotting our companion pattern will align nicely with the tick marks we've created horizontally. So that just is a nice way to do it. You could choose any scale, but why not choose a really easy one? All right, a vertical scale, we're usually just going to choose one, and that'll work. One other thing we want to do in this step is to go ahead and find the asymptotes equation for our cosecant graph. And there's a very easy way to do this, and I'll go into detail in this in some later videos. Basically, all you're going to do is take those inputs of the cosecant function, so whatever's in the bx form, and you'll set it equal to 0 plus pi k. Or yes, you could do pi k. I like to go ahead and say 0 plus pi k. It's just nicer to me. And you do that because the original zeros of sine, when you try to take the reciprocal of that, you get something undefined. So those original zeros for the companion will turn into your vertical asymptotes for cosecant. So you have this set up, you'll take bx, you'll set it equal to 0 plus pi k, and then you'll solve for x. And note that k is an integer, and as you substitute in different integers for k, you'll get different vertical asymptotes along your graph. So it's a really nice, concise way to represent all of the asymptotes at once. So next is step 2, we'll plot our companion pattern. So we'll plot that sine graph we've really been working on. All right, the companion pattern for sine is first 0 or x-intercept, maximum, second 0, minimum. So a little bit more detail on that. You start your sine pattern when it's unshifted at the origin. That's your first 0. Your maximum will happen at that first horizontal tick mark. with the y-coordinate coming from your value for a, that was from the equation. Your second 0 will happen at the second horizontal tick mark, and your minimum will happen at the third horizontal tick mark with a y-coordinate coming from the opposite value of a. So hopefully you see why we chose to break the horizontal axis into 4 parts, the period divided by 4, because these are the points that will align with the horizontal tick marks. All right, this is the pattern when your a is greater than 0, and so that means you have an unreflected sine graph, so it's not reflected over the x-axis. If your a is less than 0, your pattern, you'll follow the same template, but your pattern will go 0 minimum, 0 maximum, because the graph will have flipped over the x-axis. So that's just an adjustment in naming the actual pattern. All right, quick tip before we move on. In this step, we are graphing the companion function, so the sine graph. And in step 3, we're going to create the reciprocal graph. So it's just nice to know what you're doing in each step and where you're creating the actual graph that you want. All right, so step 3 is recip, sketch, and repeat. So recip, we're going to create the reciprocal graph by taking the y values along the graph and taking the reciprocal or flipping them. So what's going to happen, a closer look, like we said, the zeros of sine will turn into the vertical asymptotes of cosecant. So the 0 becomes the first asymptote. The maximum will become a local minimum of the graph. The second 0, of course, will become the second asymptote. And the minimum will turn into a local maximum of the cosecant graph. And we'll look at that in kind of a general form in a couple slides. Once you have those reciprocal values graphed, you'll just sketch the graph to create those cosecant curves, and then you'll repeat for as many cycles as you need. So here's the template I mentioned at the beginning. It has everything we just talked about, all the details, but organized into something that you can use every single time you create a cosecant graph. I will post a lot more videos that have worked out examples of several cosecant graphs that are unshifted, so check those out. It will really make all of this method and sort of general detail make a lot more sense. To give you an idea of what this process looks like, I'm going to show you how that reciprocal process looks. So we're not going to worry about any labeling of axes or any specific equations. We'll say we have a sine companion equation just in the general form, a sine bx. And so let's say we went on to step 2 where we plotted the companion pattern. So just lightly do this. We'd have a 0, a maximum, a 0, a minimum, and then you would repeat. And so you would have your sine companion like this. And from this graph that you create in step 2, you'll do step 3 where you take the reciprocal. So your asymptote comes from this first 0. Okay, and then you take reciprocals as you go along. So for example, of course, the reciprocal of 1 is 1, but to get a better idea of the shape of the curve, let's take the reciprocal of 1/2. So that's 2, 1/2, 2, okay? We know that we would have another vertical asymptote where another 0 happens from the sine companion, and a couple more reciprocal values here. If you take the reciprocal of -1/2, you get -2, -1 is -1, and another -1/2 is -2, and you'd repeat another vertical asymptote at that next 0. So you can very clearly see the cosecant curve. We can sketch this in, and so this should give you kind of a general idea of what these 2 steps are going to look like. So you plot your companion sine graph lightly, and then when you take the reciprocals, this is what you should be expecting your graph to look like. Something like this. This is the general shape of a cosecant graph. And I think that will make it a lot easier as you work specific examples in knowing what it should look like. And of course, then you would repeat for as many cycles as you needed. All right, so that's the 3 steps to sketch method for unshifted cosecant graphs. Hopefully this gave you a pretty good background on what you need to do, and be sure to check out some of the videos of worked examples of this method in action. I'll put links in the video description. Good luck, and thanks so much for watching.